Hello, I am going to show in this video two examples of finding the determinant of a matrix. This matrix has two rows and two columns. It's a 2 by 2 matrix. So let's start with this one. So we're going to find the determinant of this matrix. And, okay. So first of all, by definition, I'm going to write this down, starting sort of at the beginning. The determinant of a matrix A, B, C, D is found, well, it just follows this formula. It's AD minus BC. That's the formula. Okay, so if we look at this guy up here, the determinant of A is given by, well, let me just go ahead and calculate it. First, one thing I want to point out is that often we write the determinant by putting these, those lines, those vertical lines. All right, so this is determinant. Actually, maybe I like those lines. It can be very, looks a little nicer sometimes. So I'll just put here 1, 2, 3, 4. And okay, so this is just going to be, well, we could go, sort of get excited about this and show a little patterns here. So we multiply the A and the D. So that in this case would be the 1 and the 4. So it's going to be 1 times 4. And then we subtract the B times C. So that would be 2 times 3. And that equals 4 minus 6, which is negative 2. Now, the applications for these is another issue, another question. But that is how you find the determinant, okay, of a 2 by 2 matrix. All right, now, I'm going to go on to a 3 by 3 matrix. And this is one way to do it. It is not the only way. And in fact, it's not really a very efficient way. It's sort of a beginner's way, which is okay, I think, since it's only 3 rows, 3 columns. But if we have larger matrices, which just have higher dimension, then that's an issue. This method would be time consuming, and if you were having a computer do it, the computer wouldn't want to do it. It'd take up too much data and time to do it. So, but anyway, that's another thing. So there's more efficient ways to find the determinant than the way I'm showing here. But for 3 by 3s, it's pretty. It seems like it's okay. Okay, so we're going to find the determinant of the 3 by 3 matrix B. Okay, so this is B. We're going to call that B. Okay, so how are we going to do this? Well, it turns out that you have to know how to, for the method I'm showing, you have to know how to find a 2 by 2 matrix in order to find a 3 by 3 matrix. So, okay, so this is what we do. So the determinant of B is as follows. What I'm going to do is actually, I'm going to see if I can just save myself a little bit of work because, why would I want to do that? Because I'm sort of lazy in this regard, or I don't know. Not just lazy, maybe it'll make this video go a little faster. Okay. So I have these things, I've written them 3 times. Now what I'm going to do is I am going to expand across the top row. And you can expand across a row or a column, not across diagonals, but you can, and actually you can pick any one you want. So I'm going to expand across this top row, and actually let me start off with this way. I'm just going to start with that 3. That's the first guy that comes on there. And I'm going to put a 3 there. And then I'm going to multiply by a determinant, but it's not exactly what I'm showing here at all. So then I'm going to come to the next one, which is a -1. And actually, I'm going to subtract that next one. So I subtract the -1 there. I'm going to color that in. Let's make it bigger. Color that, and then I want to color the other one green. And then I come to, it's too much, right? Too many colors going on at once. But anyway, here I already started. Then I come to 2, and I'm going to put that 2 right here. But that is going to come with a plus. Okay, so it's going to go +3 minus -1, but it's still minus, and then +2. Then what do we have here? I have these matrices, but actually we're going to find the determinants of those. So this is a little bit of my problem with what I'm doing here. Is I don't want these to be matrices now. I want to find the determinant. So I'm going to sort of cheat and just scribble that out. So I'm going to find the determinant of those matrices. Well, hold on. Those are the same ones we started with, so that doesn't really make sense. But I have some plans here. Okay. What I'm going to do now is I am going to cancel out for this first guy. Okay, so I'm starting left-hand corner where there's a 3, that's green. What I do is if I cross out the row in the column that has the 3 and see what's left behind is a 2 by 2 determinant. And now I'll go over and see if I can get a sort of a similar color here. I see this -1. I'm going across the first row. There's a -1. I cross out the row and column which has the -1. And then same thing for the 2, going across 2, I cross out the row and column that has 2. And that leaves me now with a row expansion where I have the determinant of B is given by 2 by 2 determinants, and that's why we need to know how to find 2 by 2 determinants. You can pick any row or column. However, there is a little bit more to this because the pattern of plus, minus, plus will change depending on, it might not be the same depending on which row and column you have. But that maybe I'll come back to later, but I'm just going to focus on this right now. So then I'm going to write these determinants down. So usually I would just not do that step that I showed above there, but that's, the first time around. And it's tempting once you do this a lot to just start doing these in your head, but that's sometimes where mistakes are made. So, and then it's also possible I'll make a mistake as I do this. You can look these things up on, Wolfram Alpha. You can enter in the matrix and it'll give you the determinant. That's a possibility. I'm sort of just looking over this. It's sort of a waste of time if I make a big mistake. The video is a waste of time if I make a mistake. Okay. So here I have the 3, and now I'm going to find the determinant. And should I go ahead and show that method that I did of finding the determinant that I showed before? What colors was I using? Anyway, I'm gonna go across that main diagonal. That's going to be, we're going to find the product that way, and then we're going to subtract the other diagonal. Okay, so this is going to be 0 times 3, and we subtract -1 times -1. Then, okay, here's the thing. We're subtracting, but minus -1 makes +1. All right, well, there's some stuff that goes on here, so it can be a little bit tricky, but you have to pay attention. Yeah, it definitely takes some concentration. All right, so we're going to get 0 we're going to get 0 minus 1 for that 3 times 0 minus 1 plus 3 plus 1. There's all these, positive and negatives multiplying, so we have to know those rules. And then we're going to have negative 1 minus 0. All right. 3 times negative 1 plus 4 plus 2 times negative 1, which is equal to negative 3 plus 4 minus 2. Was at the very end, I'll make a mistake, could be. And this apparently is negative 1. Okay, so what did I not do? I did not explain why would we want to know what these are for. I didn't get into that at all. So that's another topic. But I did show you how to find this. And this is not the only way to do it. It's not necessarily, it's actually not the most efficient way, I think, but it's a decent way to do this. There's other ways though. So, okay, that's how to find the determinant of a 3 by 3. If you're doing a 4 by 4, you can actually do the same thing where you go across the first column and you go plus, minus, and then minus. So it alternates, plus, minus, and you cancel out the rows and columns containing those entries along the first row. So you can use this to find the determinant of any square matrix, but it's not really efficient at all when you get to larger ones, larger matrices. Okay, well, I'm trying to get that all on one screen there. So I guess that's all.